All right, guys. In this video, you have acceleration due to gravity problems. On the following one, number 1 says, a boy threw a rose to his girlfriend on the balcony. The rose stopped rising in 2.9 seconds. How high did the rose rise? I went ahead and put that time here was equals to 2.9 seconds. That's what we're being given. How high did the rose rise? He's here on the ground and he throws up his flower, okay? You know that at the very top point, just make a note that his final velocity at the very top is going to be equal to 0, okay? Now, if we're being asked to solve for how high he threw it, or how high that rose went up, we're looking for distance, for, in this case, dy. The reason we say y is because it's going on the vertical axis versus the horizontal axis. Now, the equation that you'll be using is equals to 1/2 gt squared. Make a note that again, g is equals to negative 9.8 meters per second squared. That is just a constant. It's always going to be equal to that number, guys. So then you can basically solve for your dy. If we plug in our information, we say dy is equals to 1/2, or you could say 0.5, it's the same thing, times g, which is negative 9.8, times 2.9 squared. Okay, now if you plug in your information right here, you'll probably end up with a 0.5 times negative 9.8 is going to give you negative 4.9. You multiply that by your 2.9 squared, and you're going to end up with an answer of negative 41.21. Okay, and since this is distance, it will be in meters. And that is your final answer for that problem. Now, if you're looking at the rest of them, number 2, I'm going to go ahead and give you the equations that you will be using for the rest of these problems. On number 2, you will be asked to solve for the velocity. It says a rock dropped off the roof and reaches the ground at 2.6 seconds, so this is your time. What was the velocity at impact? In this case, you're going to be solving for v of f, which is going to be initial velocity plus g times t. In this case, you're starting at rest, so VI is, make a note that it will be 0. What was the distance? Using the same time that you have on problem number 2, you're going to solve for distance, so you're just going to do dy is equals to 1/2 gt squared. Remember where g is going to be equal to negative 9.8 meters per second squared. And then in this case, your time is going to be the time that you have here, which is just 2.6 seconds again. Number 4, you're being given time, 3.8 seconds. You're being asked to figure out the max distance. So in this case, same thing, same equation, dy is equals to 1/2 gt squared. On number 5, you're being given the time, and you're being asked to solve for the velocity. So for number 5, you're going to use the same one that you used on number 2, vf equals vi plus gt. In this case, vi is again 0. Okay. Looking at number 6, what was the distance to the roof? For number 6, same equation. Number 7 is a little different, but as long as you put your information into your equation, you should be able to solve this. You're going to use VF is equals to the square root of VI squared plus 2 times G times your distance at that vertical. Number 8, you will solve for time. If you rearrange the equation that we have on number 5, you'll be able to get that time is equals to final velocity minus initial velocity, all divided by g. G is that constant. Don't forget, g is still negative 9.8 meters per second squared. On number 9, how far did he fall? You're going to solve for that again, 1/2 gt squared. And then finally on number 10, the same thing you did with number 8, you're going to use that same exact equation again. You're going to say that t is equals to v of f minus v of I, all divided by g. Okay, hopefully this helps and you should be able to work out the rest of your problems. As long as you write this information down, all of your equations on here, and you are telling me your answer, make sure to box your answer on the edge the way I did right there. And this is due by Tuesday when I come back. Bye.